Very good evening. All right, today we are going to look at the work given on electricity, part one. All right, the quizzy work given to you, and I'm going to focus only on question which is tough. All right, like question number one, we know that the flame was spread, okay, to both plate because the heat from the flame would ionize a molecule to produce positive ion and negative ion. So negative ion will be attracted, right, to the positive plate, and positive ion will be attracted to negative plate. So the flame will spread to both plate. All right. So the same go to question number two. We know is coulomb, easy. And the third one, all right, they ask you ampere hour. The ampere hour is a unit for electric charge. How many coulomb is in 1 ampere hour? So we're going to do the calculation here. All right, because we are talking about 1 ampere hour. All right, and you know that the physical unit for current is ampere, so we're going to keep this. All right, but the time is not in hour, so we're going to change the time to second. All right, because 1 ampere hour meaning 1 ampere times 1 hour. So this 1 hour, we're going to change it to current. All right, is going to be, all right, 60 minutes. All right, and in each minute we have 60 seconds. So you're going to have a 60 times 60 that will give you 1 ampere multiplied with 3,600 seconds. Therefore, you're going to get as 3,600 ampere second, which is actually coulomb. All right. They will explain why the answer is a C. All right. And then we are going to go to the next question. You will see question number 4. All right. Okay, you will see question number 4 there. Let me erase what is on the screen. All right. And we're going to move on to number 4. A battery is connected to a bulb. Okay. What is the time taken? So you know the formula for current is given by quantity of charge over time. So they ask you to find time taken. So you're going to exchange the position of I and T so that you're going to get a Q over I. And what you do is, all right, Q is the coulomb, 2 over current. Current you are given in milliampere. So what you do is you're going to change it to ampere times 10 power negative 3. All right, then you're going to move the indexes. You're going to move up. You're going to cancel 2 and a 2 to give you a 1. Therefore, you're going to get a 10 power 3, which is equivalent to 1,000 second, because the unit for time is in second. All right, therefore the answer, no, it's 1,000, right? I missed by 1 0. All right, okay, 10 power 3 will be 1,000 second. Is that clear? So we're going to move on to the next one. All right, which is question number 5. Is very direct. V equals to IR. I'm not going to talk about it. So you know that the relationship between R and L, understood, all right, is going to be direct proportional. All right, we all know that resistance is directly proportional to length. Therefore, the graph will be a what we call direct proportional. That's why answer is a donkey. All right, let's move to number 7. I'm going to enlarge it. All right, you'll be able to see that P is actually arranged in series. So what do you learn about series? All right, okay, we know that in a series arrangement is going to give us the highest, all right, the highest resistance. So resistance for P will be the highest. But in terms of current, it will be the minimum. So current for P will be the minimum. Clear? And let's talk about parallel. So fully parallel circuit is going to be circuit number 2, which is Q. They will give you resistance of Q to be the lowest. But when you talk about current, it will be the opposite. All right. If you talk about current, it will be opposite. So current for Q will be the highest. So when you do arrangement, understood, okay, they ask you to do arrangement, which one will be the biggest current and which one, okay, will be the smallest current. So let us take a good look. All right, we know that current for Q will be the highest. All right, this will be the highest. So it will be occupying the left side, okay, for Q. I'm going to use a small letter Q, and understood that current for P will be the lowest. So I'm going to put on the extreme right side for P, okay? Right, therefore you're going to have this, and understood the other arrangement, which is R will be combination of series and parallel. It will occupy the middle one. So I for R will be in the middle. That's why the answer is given as, all right, the button in green color. Okay, so with that, we're going to move on to another question. All right, which is going to be number 8. Let's take a good look at number 8. All right, what happened to resistor reading of V1 and V2 when resistance of rheostat is increased? So to answer this question, it'll be good if we come up with our own example, and then we are going to what we call give value, so that you'll be able to see what will happen. All right, when we make the changes. All right, when we make the changes, you'll be able to see what will happen. All right, then you can make comparison. Okay, let's take a good look. All right, so allow me to put the draw our own circuit. Okay, let's say I'm going to put the resistance here. Okay, we are asked to increase the resistance of rheostat. Is that correct? So what I do is I'm going to probably put all right, 2 ohm here. All right, and a 2 ohm here. So it's going to be 4 ohm total, but I will put the total potential difference 8 volt. Okay, so we are going to do the original calculation for V1 and V2. All right, then you can make the comparison between V1 and V2 when we increase this one, rheostat. You see the arrow, there's a rheostat. So we're going to have V1, we're going to have V2. So what we do is we're going to do the original method, which is going to be the total resistance. All right. Okay, we're going to put effective, and it's going to be series. So we're going to add up the resistance. All right, that will give you a 4 volt. All right, okay, sorry, 4 ohm. Right, that will give you a 4 ohm. Then I'm going to go to the second step, which is going to be total current that flow through the circuit. So it will be total potential difference Bu over R. Right, that will give you a 2 ampere. And then we're going to proceed to, all right, the potential difference reading for Bu1 and Bu2, and we know it will be the same number because your R1 and R2 will be the same. All right, okay, R1 and R2 will be the same. That will give you a 2 times 2, that will give you a 4 volt. All right, and we're going to do the same thing for V2. All right, basically you're going to have the same number because of 2 and 2. All right, that's why the total voltage or potential difference become 8. So what we do now is you are asked to increase the resistance of the rheostat. So what I do now is I'm going to increase it to, let's say I'm going to increase it to 6 ohm. So allow me to use blue ink. Okay, I'm going to cancel this, put a 6 ohm there. So I'm going to redo the calculation. All right, so that you are able to make comparison when I do, okay, I'm going to move a little bit to the right side. Hang on. All right, allow me to make it bigger a bit. All right, so I'm going to do the calculation there. All right, okay, using the same step, total resistance. We know it's going to be a 2 plus 6 that will give you 8 ohm. All right, so the second step understood, it will be current equivalent to, okay, we have the total potential difference, right, which is still 8 volt over 8 ampere. Understood, your current is downgraded to 1 ampere because higher resistance. So the third step will be still V1 and V2, all right, which is going to be I R1, and we know that the current is 1, all right, but your resistance for R1, all right, this is going to be R1, okay, is kept as a 2 ohm. Then you're going to, it will remain as, all right, it will become what we call a 2, right, it will become a 2 volt. And let's take a look at number 4. So I understood number 4, which is going to be V2. It's not actually number 4. So IR2, and you know that this has been increased. all right, to a 6. All right, so I'm going to have a 6 volt. So what could you see there? You could see that the reading of V, I'm going to use a red, green ink. You're going to see the reading of V1, which is supposed to be 4, now decreased to 2. You notice that? And then let's take a look at the reading of V2, which was supposed to be a 4, now increased to a 6. So in other words, all right, V2, all right, drop, okay, from 4 to 2 decreases. All right, I repeat one more time. V1 decreases from forward to toward, but V2 increased from 4 to 6. All right, so you know that the answer is right at the bottom. All right, okay, the one with the green button, reading of V1 decreases, but reading of V2 increases. Do I make myself clear? All right, I think it's very clear, right? With this example, with the comparison in the questions is as clear as the sky. All right, let's move on to the next question. All right. So, all right, this is talking about the terminal potential difference, all right, and what is the internal resistance. So what you're going to do is you can apply the formula that you have learned earlier on, all right, which is going to be something like this formula, all right, V equivalent to, you have two value of V, right? Right, V equivalent to electromotive minus IR. Do you notice that? Do you notice that there are two reading of potential difference in unit volt? Understood, the bigger value will be electromotive, which means it's going to be 1.5 electromotive, and the other one will be potential difference 1.2. It has always been like that. Minus I 0.2. So you can see very clear, we're going to move negative 0.2 R to the left, become positive 0.2 R on the left side. All right, and then 1.2 volt, we're going to move it to the right side, minus 1.2. Therefore, you end up getting a 0.3 on the right and 0.2 R on the left, which will give you R equivalent to 0.3 over 0.2, which will means 3 over 2. There you go. You're going to get the value 1.5 ohm. Basically, it's an easy one. Do I make myself clear? It's almost similar with question number 10, as you can see there. All right. Okay, it's almost similar with question number 10. All right, you are given electromotive 3 volt, internal resistance 0.5, connected to a resistance 1.5, the current. So what you're going to do is you're going to total up the total resistance. All right, so let me erase this part of the work. Okay. All right, basically, okay, you may use back the same equation, or okay, never mind, I will use the whole thing again. So the first step, as usual, you are going to add up. This is very clear, like normal question, right? You're going to add up the total resistance which you are given. All right, okay, the resistor of the circuit 1.5 plus internal resistance 0.5. There you go. You're going to have the total resistance 2 ohm. All right. This is like normal question in Form 3 standard. To find current, you will be total potential difference, all right, over total resistance, which will give you, all right. So in this case, we are going to put the total potential difference as electromotive, all right, 3 over 2, because it includes internal resistance. Therefore, you could see very clearly the answer is going to be 1.5 ampere, the green button. All right, let's move to the next one. All right, so question is talking about at the beginning, all right, electromotive is 6. All right, okay, electromotive is 6 in the diagram at the top. All right, diagram at the top, you see diagram at the top when the circuit is off. All right, what is the reading given by the voltmeter when the switch is closed? So when you close it, current flow. All right, current flow, there will be the presence of internal resistance. That's why the value or the reading of the potential difference will drop, all right, because you need to minus the energy spent, all right, to overcome internal resistance, right? That's why your calculation of the formula, by applying this formula will look like this, all right, look like this, all right, you are going to do V equivalent to E minus IR. So when you on the circuit, all right, current will flow, then it will make, okay, these two to be functional. So what happens is you're going to have the electromotive 6 minus 1 value. Even if the current is very small, 0.1 ampere with the internal resistor 1, so you end up getting a smaller value for your potential difference, which is the reading of your voltmeter. Right? It will turn out to be a number which is going to be smaller than 6 volt. All right. Therefore, you see the answer there, less than 6 volt. All right. As the suggested answer given. All right. Let's move to the next question. All right. This is a simple one. Power equals to VI. I'm not going to show that. All right. And let's take a good look at this. All right. This will be using the formula current equals to Q over T. And to find your quantity of charge, all right, it's very clear. Quantity of charge, all right, is going to be Q equivalent to IT. All right, so what you do is you're going to change the time to a second. That's all. All right, with 3 ampere, all right, and the time given 1 hour with 60 minutes times 60 seconds. There you go. You're going to multiply, all right, 3, all right, with a, all right, 3600. All right, it's very clear. You're going to multiply 3. Let me clean up. All right, let me do some cleaning up. All right, it's going to be a very simple calculation. All right, it's going to be a 3 times with 3,600. So understood the value will be 10,800. That's why you see the answer is in the green button. All right, in unit column, because it is charge. Do I make myself clear? All right, and I guess this is the last question. All right, this is going to be the last question. It's an easy one. They ask you which one uses the least energy, right? Least energy. So what you do is you are going to use the formula and make comparison, all right, to find the least energy, which is, okay, give me one moment. All right, very easy job. All right, we know that least energy, okay, which will give you power equivalent to energy over time. So you want to find energy, right? Then what you do is you're going to cross multiply energy equivalent to PT. So what you do is you're going to multiply power, given power in the second and middle column and the time. All right. And to get the least understood, your value of your energy after your multiplication, it must carry the minimum number. All right, because question asks for the least. There you go. All right, you just check out the number. The answer will appear to be, all right, electric iron. If you're good in maths, you can take a good look. All right, electric iron. All right, it will give you 2,000 times 0.3. It will give you 600. All right, the second one 600. The first one 1,640 times 40. All right, the third one is conditional 1,000 times 2, 2,000. All right, and the third one, 85 times 15, it will be close to 1,000. So the smallest one will be electric iron, which will give you only 600. All right, okay, with that, we'll come to the end of this session for electricity, part 1. All right, I'll go to part 2 in our next video. All right, see you then. Bye.